How are we doing?
Splendid.
Okay.
Splendid.
Um, it is almost Friday, which is lovely. So people are asking, is there a quiz today? And I overheard people complaining that they didn't get in it, didn't know. What's the deal with the quizzes in this class? Okay. Let's just refer back here. I know. Homework quizzes. At least one per chapter. The homework quizzes will be unannounced based on recent homework assignments and closed book. Grade on 10-point scale based on overall demonstration of understanding. Okay? Everybody? Okay. So the plan is to do this today. Here's the deal though. I'm going to take questions from homework before we do anything. So if you don't know what's going on in the homework, you'll have an opportunity to at least ask before I pass anything out, and you can get...
Is this for the first and second homework? This is just...
Yeah, 1 through 18. So anything on one... Okay. Okay, time out for a second. Let me also point out to you, so look at how your grade is decided. The homework quiz, how much is that relative to everything else? Is that the least important thing, right? Just, you already have a homework quiz grade in the grade book from the first day.
It's a 50%.
Also, look at the, where did I have it?
We get quiz retakes.
Look at the end of the semester.
Low homework quiz grade will be dropped.
Yeah, at least one. Okay? So just everybody,
Just try.
just take a deep breath. Delaney, do you have a question? You want to start?
What happens if I know I'm doing glitter right now?
I have 4 in my desk. You could borrow one of those.
Perfect.
Okay? Let's just everybody relax. Yes, sir. Of course you can. Yeah.
Yeah, can I win?
So I have 4 total. I think that's 3 people that have asked. That's fine. Okay. What is the quiz on? The quiz is going to be very similar to the homework problems that we've assigned 1 through 18. Okay. Have you started the homework yet?
I've had some essays to write.
Okay. I understand. This is, but let me be honest with you. This is part of the reason why the homework quizzes are in existence, is to try to get you to not kick the can on all the homework until Sunday when it's due, is so that you're still making sure. I need something to hold you responsible to keep doing the homework during the week as well. This is that carrot to keep you doing the homework like each day. I know you feel like this isn't fair. I understand. I'm listening and I'm sympathetic. I really am. You can be mad about it. It's okay. You can be mad at me. That's okay. I'm not going to take it personally.
You're hard to be mad at. Very nice.
Well, it's also because I don't want to be mean about this. I'm not trying to do this to be hard on you. It's not like I'm trying to ambush you to make you have a bad grade. I don't want that to happen. Okay? It's part of the reason why we're going to take some homework questions before I pass this thing out. I will answer as many as you want to ask, as long as it's reasonable. Delaney, can we?
We did one of the domain problems.
Absolutely. Do you have one in particular you're interested in?
No, I just want to make sure I was doing it right.
Okay. Does someone else have one that they're in particular interested in? Yes, Ava. That's not a domain problem, but that's okay. We can, but let's look at 1 of these 5 through 10 first. If nobody has one in particular,
Yeah. 5.
My calculator's broken.
why do you say it's broken? It doesn't turn on, so probably the battery's dead. When was the last time you charged your calculator?
Probably like before my math went like
Okay. So if you look down here, Mary, if you look down here, there's an extension cord with calculator chargers plugged into it. Why don't you go plug your calculator in right now so you can get some charge on it right now. Okay? Don't forget to pick it up before you leave. But any day you need to charge your calculator, you can plug it in during class, and I'm happy to provide, a couple calculator chargers. Sure. Okay. All right. So Delaney wanted to look at one of these. I'm going to pick one since nobody else has picked one. I'm going to pick number 9. Okay. Okay. So when I look at a domain problem, I want to first start by looking at the operations that are involved in this problem. So when I look at this problem, what operations do we see? A square root and subtraction. Everybody's okay? We see the same things? Okay. If I take two numbers and subtract them, is there any way that I don't get an answer to that problem? Right? Can I subtract any two numbers and get a number back? Yes, right? So subtraction, no problem for our domain. We don't care about it. Can I take the square root of any number and get another number back? No. Great. What kind of numbers cause us a problem when we're square rooting? Negatives, right? 3, you get a decimal, but that's okay. Decimals are fine. Negatives, though, what happens when we square root a negative? You get an imaginary number. We don't care about imaginaries when talking about domain because when we plot numbers on the XY axis, there's not a place to plot imaginary things. Okay? So what we need to worry about then is the stuff that's underneath the square root can't be negative. Non-negative means it could be 0 or greater than 0. So I'm going to write it as greater than or equal to 0. Everybody okay with what I've done here so far? That doesn't sound reassuring. Where did I lose you?
That part right there.
Okay. So the square root can't square root a negative, right? So what kind of numbers can I square root then? 0 and positives. How do I write that as an inequality? Greater than or equal to 0. That's going to be everything that's positive and 0 also. Does that feel any better? Okay. Next step is going to be to get the x by itself on this inequality so I can get it into a place where I can draw it on a number line. What do I do to do that? Add 1 to both sides. So now the x part is by itself. I now have this problem in a position where I can draw it on the number line. So there's the number line. So this is just like a problem we would have done in algebra or even pre-algebra, right? So I'm concerned with the number 1 because that's one of the boundaries of this inequality. You can see the 1 right there on it. So let's put 1 right here. Now I'm going to put a point at number 1. Should this point be solid filled in or should it be open? Closed. Solid filled in. How do I know that? Because it's an or equal to inequality. Look at this. You guys remembered more than you thought. Okay. Now do I draw my arrow to the left or to the right?
Right.
To the right, because I want the things that are bigger than 1, right? Where the things that are bigger than 1 live? 2, 3, 4, they're all on the right side. What's up, Sid?
Okay, I got it.
Are you sure?
Yeah.
Okay. Okay. So there's my inequality, right? Or there's my number line. Everybody happy?
Yes,
I'm not done.
Yeah.
Because now I'm going to translate this into an interval. Okay? So if I look at this, what is the lower bound for that inequality? What's the smallest number involved? 1, right? Because the 1 is the beginning of my arrow. That's where my arrow starts at. 1 is my lower bound. What's the biggest number here involved? Positive infinity, because I have the right-hand arrow. It goes on forever. Now I need to assign the lower bound and upper bound either a parenthesis or a bracket. Do you remember what we do with the infinities? Always parenthesis. And the 1 should get a bracket. Why is that going to get a bracket?
It stops.
It's not any of those reasons. It's because it was the filled in circle.
Oh, so if it's a parenthesis, then it would be the not filled in circle.
If it was an open circle, you'd use the parenthesis.
Okay.
Yes, exactly. And now we are done. Okay? So again, reviewing what we did. We started by looking at the operations involved. We decided which operations would cause us a problem. When is there a number or kind of number that when I do this operation with it, it gives me undefined, right? Is a problem that I cannot do. I write some kind of an equation or inequality to eliminate those values. I solve that, draw it on the number line, and then use that picture to come up with my interval. Did you want to do 8 next? Is that what you said?
Yeah.
Okay.
Or 10.
Sure. Which one do you want to do? Okay. Oops, that's okay.
So there's part of the homework, like, where you
Was it like graphing?
12 or whatever.
1 through 12 was the first part, and then 13 through 18 was this.
No, like,
What was
I
it?
haven't looked at it yet.
Oh, well, you're looking at 5 through 8 right now, which is domain.
Is that the second part?
The second, what do you mean the second part?
Wait, oh, this is.
Are you okay?
Good.
Okay,
It's
it's okay. Just take a deep breath, it'll all be okay. Bladen.
I have a question.
Okay.
On this? I don't know. So like there's just greater than and there's less than. Do I use that during these? Or do I just use greater than or equal to? Or did I even do that right?
You didn't do this one right,
Okay.
because the only operation is involved is subtraction.
Yeah.
And you can always subtract 2 numbers, right?
Yeah.
Wait.
So there is no restriction here. Your domain is just negative infinity to positive infinity. It's
Can
everything.
you show me how to do that?
There's nothing to do.
How do I know then?
So the answer, can we do this one that we're
Yeah,
in the
sorry.
middle, and I'll be happy to circle back to 5. Okay?
Is if it's a negative, is it always gonna be greater than or equal to?
No, it's because it was under the radical that it was greater than or equal to. If it was x plus 1, it would still be greater than or equal to, as long as it was under the radical.
Alright.
You know what I mean by radical?
Not really.
Square root symbol.
Okay.
If I use a term that you're not sure on, like stop me and ask, okay? Like my answer is of no consequence if you don't understand the terms involved. Okay? You know, like do me a favor, don't pretend to know more than we know. Just like be honest with what you don't know or not, and it'll go much better. I can always adjust. I want to be effective. I want to do a good job. I want you to learn and understand this. We can go slow if we need to.
Oh, no, I do get it now.
Good.
Okay.
Okay. So we're trying to do number 8.
Yeah.
What operations do we see going on in number 8? Division, subtraction, and an exponent squared, right? Does everybody agree with that?
Yeah.
Okay. We talked about subtraction already. Can we always subtract 2 numbers? Yes. So that's fine. Doesn't affect our domain. How about squaring? Can I always square a number? Yes. Doesn't affect our domain. Can I always divide 2 numbers? No, because I can't divide by 0, right? Everybody remember that? Okay, so that's the piece that's going to affect my domain, is I'm going to take what's in the denominator and say that that cannot equal 0. Everybody's okay with that? Because we said dividing by 0 is a problem. I'll take the denominator of the fraction, or the divisor of my division problem, and set that not equal to 0. Now I'm going to solve this equation. What should I do first to solve this?
Add the 1.
We could add 1 to both sides. Sure. Great. Next, what should I do? Square root both sides, yep. That was the symbol that you were drawing. You just didn't remember the name, but that's good. Now, we have to be a little bit careful here. When we square root both sides of an equation like this, what happens? Plus or minus. Very good. So it generates a plus or minus, and then the square root of 1 is just 1. Everybody's okay with that? Now, what does this really mean? Well, plus or minus is the same thing as saying x cannot equal 1 and x cannot equal negative 1. Yes, Tom?
It has a fraction. We always do that with the denominator.
As long as the denominator has a variable in it, yes.
Set it to 0.
Yes. Set it not equal to 0, but yes. Yeah. Well, no, we haven't drawn our number line yet, right? Or written our interval. So here, notice that we don't have inequalities, right? This is a little bit different because we have these not equal to statements. So for sure we get that the number line is going to involve -1 and +1 since our statements say x cannot equal -1 or +1. Everybody's good with that?
Yeah.
And if it can't equal -1, at -1, should I draw an open circle or closed circle? Open, because it can't be -1, right? The open circle was not including it. And similarly, I'm going to do the same thing at +1, right? Now, every other number is fine. You guys agree with that? Because every other number is not -1 and not +1. So really we have like that as our number line. Is everybody okay with what we've drawn so far? No. Okay. Talk to me.
Why does it go like that?
Okay. So our domain is x not equal to 1 and x not equal to -1. So every other number is okay, right? -2 is fine because it's not -1 or +1. 5.6 is okay because it's not -1 or +1. So that's why we've drawn, like connected everything else, because it's everything that's not -1 or +1. Is that now okay?
Yeah.
Ish?
Yeah.
Okay. So if I look at this, it looks like there's 3 distinct parts, right? Everybody agree with that? Those 3 distinct parts are going to be 3 separate intervals. Okay? So looking at this first piece, the smallest number involved, the lower bound, is -infinity because we have the arrow pointing to the left. Everybody agree with that? The upper bound, the largest number involved, is the -1 because that's the stop, right? It stops at -1. That's the end of that arrow. Now, should I use a parenthesis or a bracket on the -infinity? Parenthesis, because all infinities get parentheses. And on the -1, should I use a parenthesis or a bracket? Parenthesis. Why, Nico?
Because it's an open circle.
Because it's an open circle. Boom. First interval done. Okay. Then we're going to use the union symbol to connect them. And we're going to look at the next interval. If I look at the next interval, what's the smallest number involved? -1. That's the thing on the furthest to the left. What's the largest number involved? +1. Very good. Now, we need to decide, does -1 get a parenthesis or a bracket? Parenthesis, because it's an open circle. Does the +1 get a parenthesis or a bracket? Parenthesis, because it's an open circle. And we'll do another union, and we'll do our last interval. What's the smallest number involved? +1. And the largest? +infinity. You could write regular infinity too. It's not wrong to do that. I always put the plus there because it reminds me to put the minus. Okay. The 1, parenthesis or bracket? Parenthesis. The infinity, parenthesis or bracket? And we're done. Okay. That was probably the most challenging one, as it has the most complicated interval that you had to write at the end for 5 through 10. Nico?
How many questions are on the homework quiz?
3. Not graded right or wrong. It's on overall demonstration of understanding. I'm going to look at your work and go, you could get all of them wrong and still get like an 8, right?
So out of 10.
Yeah.
Oh, I thought it was graded on like.
Demonstration of understanding.
Oh, no, I'm stressing.
I'm still stressing. I don't get this.
Okay.
I'm getting that.
Okay. Bladen, you want to talk about 5, right?
Yeah.
Let's talk about 5 for a minute.
Yeah, but I was only
Okay. So first thing we do is look at the operations involved. What operations are involved with number 5? Subtraction. Can I subtract any two numbers and get another number back? Yes. So what does that tell me about the domain? Is that everything works, right? How do I say everything in mathematics?
all.
I say all real numbers, or I write -infinity to +infinity. That just means everything. All the numbers work.
So if we have just subtraction, it's gonna be that.
Yep. Or if you have just addition, or if you have just subtraction and addition, because everything works for those. Or if you have just multiplication, subtraction, and addition. Hi, Paula. Thanks.
We don't have to show work. Like, wait, that's all.
Well, for something like this, no, you wouldn't have to show any. There's nothing really to show.
That's it.
Yeah.
Can you explain?
Yes. Shh. Okay. So Avery asked me to explain number 5 again, and I think that that's a good idea, right? So, again, we start by asking ourselves what operations are involved. Subtraction is the only operation involved. Then I say, okay, if I take two numbers and subtract them, can I do that for any two numbers and still get an answer back? And the answer is yes, right? Any two numbers you want to subtract, I will always get another answer. I will always get an answer. So that tells me that all numbers are going to work inside of this function, right? The way we say everything works in mathematics is we'll state all real numbers, or if we need to write an interval, we write it as -infinity to +infinity. So the smallest thing you can come up with, all the way to the biggest thing you come up with, all of those are things that we could plug in for x and get an answer back. Does that? So if this was x plus 5, what would the domain be? +infinity, -infinity. What if it was 2x minus 5? It's still -infinity to +infinity, right?
What did you say it was? If it was x plus 5, it would be positive.
Same thing.
So if it's only
Same thing
subtraction
as that.
adding,
Mhm.
no matter what the variable is, if it's subtraction, it's gonna be an infinity.
Yeah.
So it's only negative infinity first if it's a subtraction.
No. When you say all real, okay. This is how you write everything in mathematics. If everything works, it always is written as negative infinity to positive infinity. The signs in your function do not matter. If it was 2x, if it's f of x equals 2x, the domain is still that. If it's negative, or f of x equals negative 2x, the domain is still that. If it's f of x equals negative 4x minus 7 all divided by 8, the domain is still that. Because all you're doing is doing operations that work for everything, right? If you multiply any number by x, well, you can always do that. You can multiply any two numbers together. If you add any number to x or subtract any number to x, that always works. If I do both of them, it's still always going to work. If I divide by a constant, if there's no variable in your divisor, you can always do that, right? Those things will just always generate all real numbers. So if I look at, say, number 6, it's all real numbers because I can square any number and I can subtract any two numbers. It's all real numbers. It's still negative infinity to positive infinity.
7.
Well, 7 is not because there's a divisor or variable in the denominator. So if the denominator is 0, which it could be because it's an x, it doesn't work, right?
So what did you say also?
So 7, you're going to have to do the same kind of thing we did for 8, right? It'll be,
Take the x and set it to 0.
you set it not equal to 0, which is already solved. So you go straight to drawing your number line. You have the open circle at 0, arrows going to both sides.
Or it's positive infinity.
So you have negative infinity to 0, union 0 to positive infinity.
I don't understand.
Okay. Do you want to look at one of these from 1 through 4?
Yeah.
Okay. Let's do that. Sure. So Reese asked to do number 3. So when we're given a function that's written as an equation, we're asking, or I'm sorry, if we're giving a relation written as an equation when we're trying to figure out if it's a function or not, typically what we're going to want to do is graph it on our calculator and look at the picture, right? The problem with what's the problem with doing that with number 3? The y isn't by itself. So what are we going to do?
Divide it.
We're going to get the y by itself so that we can get it into our calculator. The first step would to be divide by 2. Okay, you're just like one step ahead of me. That's great, though. Okay, now what should I do? Square root. And what do I have to remember when I do that? Plus or minus. And remember, the squared cancels the square root. So what we're going to type into our calculator is this. What's the one problem with that?
There's 2 different.
Yeah, the plus or minus, right? So what we do is we're going to type it in as 2 separate pieces. One where we have the positive. You could write a plus there, but you don't need to if you're going to type in your calculator. And then the minus one. So that's what I'm going to type into my calculator. And the graph that I'm considering to use the vertical line test on is the graph of both of these things simultaneously. So I'll do square root of x over 2, and then I'll do negative square root x over 2. And if it's, yes,
Got an error.
did you do, what did the error say?
Error syntax.
Okay, so use the subtraction symbol probably instead of the negative symbol. So the negative sign is there next to the, or underneath the 3 as opposed to the subtraction symbol.
Yeah.
So I'll do zoom standard because I don't know what the last time I graphed something on here was, what my window might have looked like. But this is the graph that I'd be considering. What would I say? Is this a function? No, why not? Fails the vertical line test. What work would you show on a quiz or a test? You sketch the picture and you draw a vertical line that shows it happening. That would be enough. Does everybody feel okay on something like that? Okay, doable? Okay, good.
Does the graph have to be like accurate when we draw it?
Just the sketch is fine. Like you don't have to plot points as long as the shape is basically the same. Okay. What about one of these? Well, you may just have like a corroded battery. Could be the problem. You might just need a new calculator. We'll have to see when we pass them out. If not, we'll figure it out, okay? What? Well, considering I'm picking the questions that since what we should kind of go over.
Can we do 17?
Yes, of course we can. All right. Yes, Paulie.
My calculator, when I turn it on, it just like flashes on and then it turns back off.
It could be out of battery. You might need to plug it in. I have chargers over here on the power strip. Try plugging it in for a few minutes. Okay? And on your way back to your desk, will you pull the door shut?
Yeah.
So I can hear over the lunch. Thank you, sir. Okay. Reagan. 18. All right. So, Ava, you asked to see 17, right? Okay. So here it says, use a function grapher, i.e. that's your calculator, to identify and classify all local maximums and minimums. Round your answer to the nearest hundredth. So we're looking at this one first. So I'm going to just start by turning my calculator on, pressing the y equals button, and then I'm just going to type this in the way it looks like on my sheet of paper. So x times x or square root of x minus 1. So far, so good. Okay. And then I'm going to do a zoom standard because, again, I don't know. Some of us have been doing stuff. Maybe the windows have been different. Who knows? What error did it say? Okay. So my suspicion is that you used the... Yeah, I don't know what you would... Oh, hey, do this, Sid. Scroll all the way down to the bottom and make sure you don't have a bunch of gobbledygook in one of the y equals spots.
Oh, wait.
You had a bunch of gobbledygook? Yeah, okay. That was probably it then. All right. So, Ava, I'm looking at this, right? So, we're looking for local maxima, local minima. Do we see any relative low point on the graph? Be careful.
0.
I do. It's the start of the graph right there, right? That's the single lowest point. Is there a highest point? No, right? Because it keeps getting higher and higher and higher and higher, right? You wouldn't say infinity because that's not like a point specifically. That's like a concept. But yes, you're saying that it's getting bigger forever. So we have just one local minimum. It's the very first point on our function. What does that point appear to be? Looks like the point 1 comma 0, right? Because it looks like it's right here on the x-axis. If I plug 1 in for x, we get 1 times the square root of 1 minus 1. 1 minus 1 is 0. The square root of 0 is 0. 1 times 0 is 0. So that is the point 1, 0. That's certainly a point on my function. If I picked any number smaller than 1, I'd get a negative under the square root, right? So I'm convinced that that is the starting point. So you have the only answer here is we have one local minimum at the point 1, 0. And it's actually, in addition to being local, it's also the global minimum because it's the lowest of all the points. So local means it's the smallest point in its area. Like if you're the smartest kid in your class, you're like locally smart. Global is like you're the smartest kid in the entire school. You're globally smart. Like you're the smartest of everybody. So the global minimum would be the lowest of all the points, not just the lowest in like its area. Does that? Yeah. Okay. So it is there's one local minimum, and the point is 1 comma 0. I don't have the right name written down here. Ellie Peters. Got it. Okay. Thank you. Ellie, tell me.
I was wondering, is there not a local maximum for that problem?
There is not, because the graph continues to get bigger and bigger and bigger, and there's no like little window I can draw where there's like a point that's the highest point.
Okay.
You know what I mean?
Yeah.
Okay. So yes, you're correct.
Okay.
That's good.
So we're only supposed to find locals?
Well, absolutes are locals also, right? Because if I take the highest point and look at the area around it, it's still the highest, right? Every global is a local, but every local isn't a global, right? Like every dog is a mammal, but not every mammal's a dog, right? Let's do another one of these where we actually have to punch through the buttons. Yes?
Yes.
Okay, let's try, what do you guys want to do? 16, okay. I forget even what the, okay. So I'm gonna go ahead and hit graph. I'm gonna take a look. All right. How many extrema do I see here?
1, 2, 3, 4.
I only count 3.
I looked at the wrong thing.
Okay. I have a local minimum here, a local maximum here, and a global minimum here. Globals also count as locals, right? This is 16, sorry. 16 is what we're doing. Okay. Everybody okay? To get the specific points now for these minima and maxima, what do I need to press? Not second table, second trace. And which commands sound like the ones I need from second trace? Minimum and maximum, right? Let's find that local minimum first. Okay, so look at the bottom of our screen now. It's asking us a series of questions. It's going to ask for a left bound. So if I'm looking for this point, I need to move my cursor somewhere on the left side of it. My cursor is this flashing thing right here. So I'm just going to use the left and right arrows on my calculator to move my cursor so that it's anywhere left of that minimum that I'm looking for. That spot looks all right. I'll press enter there. Now it asks for right bound. I'm now going to move my cursor so that it's to the right of that minimum, somewhere in between this minimum and maximum. Anywhere in there is okay though. So again, left or right arrows. That looks good. I'll press enter. Now it says a guess. Wherever you're at is a fine spot for a guess. Just press enter. We don't have to get fancy. So here is my first local minimum. I would just copy down the numbers written as a point. So parenthesis negative 1.528543 comma negative 1.694706 parenthesis. Yes, sir.
Oh, you like go to that type of trace, it's like the options.
So we did the minimum command because we were looking for a minimum. If you want to find the maximum, we're going to use the maximum command.
So it doesn't matter if we choose.
It does depending on what you're looking for, right? We were looking for the minimum here, so we used the minimum command. When it's time to look for the maximum in the middle, we need to choose the maximum command. Yes, because the question is asking for all the local maxes and mins. Okay? Do we need to continue going through the buttons to see the rest of these? You remember doing this last year?
Let's just go rapid fire.
Okay, let's see if you can get the same thing I did. Ah! Pressed it too many times. There's the maximum. Parenthesis negative 0.1004031, comma 3.0501008 parenthesis. Done.
What about the other minimum? Would we have to, don't we plug in both of them?
You would need to find the other minimum also, so we just go back and use the minimum command again.
And then we put the U in between the minimums? Or?
No, you can just put a comma, because these aren't intervals, these are points, right?
Yeah.
And I know that can be confusing, because they look the same, but context matters. Is that, you're okay? All right. What do you think, folks?
You know what? Give it.
Give it a shot. Okay. Clear your stuff then. Yes.
Oh, right here. 1, 2, 3.
I was the one who asked first. Okay, you want it? Where should I do?
Mine's charging over there, you can try it.
Okay.
Rachel, how do I do this?
The other option, Mary, is that you said your calculator does work when it's plugged in. You can drag a desk over here, just so you have the calculator
Okay,
access.
let's try Polly's. We'll see.
I doubt
No, looks like it's working. I mean, like, I don't.
It's doing stuff right now.
It's pressing buttons. Wait a second. Yep.
I need to look at it again.
Let's put our stuff away, right? Don't focus on wait. That's okay. Walked in late. It's all right.
Oh my God. Few days just now gone.
Upset that permanent. You give me something?
No, I don't have enough money. I'm spending all my money.
Or you want to close your health?
Do I want to? No.
Asking every single one.
I don't even want it.
I'm sorry.
What is this?
No. What is relation? No, I also just grab it.
Yeah, so just look at the graph.
Uh-oh. No way.
If it's something that's written as a way to type in your calculator, yeah, just type in your calculator. Okay. You're probably just gonna look at your calculator. It's still math, because we're using like math definitions and stuff, but there's not like a calculation necessarily. Yeah, that seems appropriate. Yep. We have to, I'll tell you, here's a gift. That is not the correct answer. So, I would try to show support, but maybe we'll get along to the right. Does that satisfy you? Yeah. I mean, it's better help, I guess. That's like vertical's up and down.
Yeah, no, I'm saying.
Not the horizontal is left and right. You're drawing horizontal.
Oh.